Hello! In this video, we'll look at antiderivatives, also called indefinite integrals. Antidifferentiation, or indefinite integration, is the reverse operation of differentiation. So when we're anti-differentiating, we're looking for a function capital F of x, whose rate of change is f. So we're starting with the derivative, and we look for the antiderivative. So here the notation for antidifferentiation, we take the antiderivative of the function, which is also called the integrand. The dx indicates we're taking the antiderivative with respect to x. This will be equal to the antiderivative plus a constant of integration. Since the derivative of a constant is 0, we can add any constant to the antiderivative, and it will also be an antiderivative. Also, note that for the notation, the integral symbol and the dx surround the function like an open and closed bracket. So when you want to take the antiderivative, they will always be written together with the function that you are integrating in the middle. So here, for example, the antiderivative of 2x with respect to x is equal to x squared plus c, since the derivative of x squared is 2x, and this is true for all x. The general antiderivative f of x plus c is not just one function, it's a family of functions that all have the same derivative. So on this graph, we can see some members of the family x squared plus c, x squared plus 3, x squared minus 3, x squared minus 6, and all of those functions have the same derivative, 2x. To solve for a particular antiderivative, a point must be specified to solve for the particular constant c. The basic antiderivative rules are just the reverse of the basic derivative rules. So in each of these cases, if you take the derivative of the antiderivative, for instance, the derivative of x plus c will be 1. And you can check that it's true for all of the rules. When we were taking the derivatives of the cofunctions, we saw that the derivatives of the cofunctions were negative. But when we go in reverse, you can remember that if your antiderivative is a cofunction, then it will be negative. If you have a power of x that is not equal to minus 1, then we have the anti-power rule, or reverse power rule. The antiderivative of x to the n with respect to x is equal to x to the n plus 1 over n plus 1. So you add 1 to the power n and then divide by that number, plus c. So here's an example for using the anti-power rule. Here we have x cubed. The power is not equal to minus 1. So we want to take the antiderivative. We will add 1 to 3, so x to the 4, and then we will divide by 4. So the antiderivative of x cubed is x to the 4 over 4 plus c. Next, we can take the antiderivative of 1 over x cubed with respect to x. But first, just like the derivative rule, we have to re-express it in the form x to the n. So here we have the antiderivative of x to the minus 3 with respect to x. And now we can use the anti-power rule. So you will add 1 to the power and then divide by that number. So minus 3 plus 1 is minus 2 divided by minus 2 plus c. And just a reminder, for the antiderivative of 1 over x, or x to the minus 1, you won't be able to use the anti-power rule because the power is minus 1. And if you add 1 to minus 1, then you'll have x to the 0 over 0. So then you can remember that 1 over x has its own antiderivative rule, which is ln of absolute value x plus c. In this example, we have an antiderivative for a polynomial. So just like taking derivatives of a polynomial or a sum, you can take the antiderivative term by term. To show we are using the basic antiderivative rules, I'll separate them into the exact forms from the list of formulas. So 36 is a constant, so I'll take it in the front. So we don't always have to do this, but here I'll separate the integral into 3 separate integrals. In each integral, it's clear I will be using the anti-power rule for x to the n. I'll keep the constant 36 and take the antiderivative of x to the 5, which will be x to the 6 over 6, minus constant 64 times the antiderivative of x to the 7, which is x to the 8 over 8, plus 9 times the antiderivative of x squared, which is x cubed over 3, plus c. And here we can simplify it. 6x to the 6 minus 8x to the 8 plus 3x cubed, plus c. So that is the antiderivative, and it's up to you. If you want, you can check that the derivative of the antiderivative will give you back the integrand. We'll take the derivative. It will be 36x to the power 5 minus 64x to the power 7 plus 9x squared. And the derivative of c is 0. This is what we had in the original question, so it's correct. Next, we have the antiderivative of a sum of terms. Each of those we can use the basic rules, so I'll separate it into 4 basic integrals. For the first term, x is squared and cube rooted, so I'll rewrite it in the form x to the n as x to the 2/3 plus 14 times the integral of e to the x with respect to x minus 5 over 2, I'll keep it in the front, and since x cubed is in the denominator, when we put it in the form x to the n, it will be the integral of x to the minus 3 with respect to x plus pi, which is a constant, times the integral of 1. So for the first integral, x to the 2/3 plus 1, 2/3 plus 3 over 3 is 5 over 3. And either you can divide by the fraction 5 over 3, or you can multiply by its reciprocal 3 over 5. Plus 14, integral e to the x is e to the x, minus 5 over 2. The antiderivative for x to the minus 3 will have x to the minus 3 plus 1, which is minus 2, divided by minus 2, plus pi times the antiderivative of 1, which is x, plus c. Next, I'll just simplify the constants. Negative times negative is positive. Again, it's up to you. If you want to check your antiderivative, you can take the derivative of the antiderivative and see if you get back the integrand. So we'll take the derivative term by term. Here we took the derivative of the antiderivative, and we got back what we started with, so it's correct. So if you want to check your antiderivative, it's always available to you.